Hey, what's up guys? Jeremy here from RoboDK. Welcome to our first ever live webinar. This webinar and all the ones we'll do in the future will cover a specific aspect or application of RoboDK. Today, we will start by tackling a very common robotics application, pick and place. As I said previously, my name is Jeremy, I'm the product manager at RoboDK, and I'll be your host for today. First, I really want to say thank you to everyone that registered for that first event. We by far exceeded our expectation in terms of people attending this webinar, so that's pretty cool, and that tells me that you want more in the future, so we'll do so. The agenda for today is pretty simple. I'll go over 3 different examples in about 40 to 45 minutes. All of those examples obviously will have pick and place as their main feature. And then at the end of the presentation, we should have 15 to 20 minutes left to answer your question. So I will need your participation for this part. At any moment during the webinar, you can ask a question, either publicly via the chat or privately. If you click on the little drop-down menu in the bottom right corner of your screen, you should see something like Ask Question. We will only answer the question at the end of the presentation, obviously, so that I can make sure to show you everything that I need to show you. I also highly encourage you guys to get involved in the chat. At the moment, you are a few hundred people connected, and I'm pretty sure you all share a common interest for robotics, so feel free to engage with one another. It's a good opportunity. And real quick to finish with the agenda, we will start by a simple pick and place application, just moving a box around. We will start this station from scratch, so with nothing in it, and we should have a finished product in less than 10 minutes. Take note that I won't show you the basic of RoboDK, so I'm not there to show you how to create a target or how to create a movement. So if you want to learn that, you can always take a look at the basic guide series I created on our YouTube channel. So you can take a look at that afterwards. We have other tutorials there. After that, we will go through 2 small examples that will show you some options or in the attach feature of RoboDK. So that will help you. It will help you with your pick and place applications. And lastly, but surely not least, I'm going to show you how to create the unload palette application that we used to promote this tutorial here. So this webinar here. So we'll show you exactly how to create that palette, how to create the targets, how to unload it on the conveyor. So yeah, that's pretty much it. That's a good amount of work to do. So let's get started already. So I'll start with a simple empty station right here. I'll open my library. I'll go and select by brand. I'll use a Doosan for today, but every single thing that I'm going to show you in this webinar is applicable to any other robot brand that we have in our library. So now that I have the robot, I'm going to need to use a tool. I'm going to add a simple static tool. Won't go too fancy for this one. A simple robotic gripper. I'll add a few objects, so a table and a cube. Perfect. Now I will create a reference frame. I will reset the position, so I can just double click on it, or click the 3 lines here or the hamburger right here, reset, or I can right click and click reset. So this is a fairly new feature, small one to make you save some time, so the right click reset. Now we just have a reference frame called world. I'm going to drag and drop the table in it, and the goal here with world is just to have everything that is part of the station but shouldn't move or shouldn't be very used in the simulation except for showcasing the environment of work, the working environment in fact. I'm going to position it at 500. You can use your scroll wheel here to change the value. So 500, this is perfect. Next step, I don't need to see the flange here. I'm just going to use the TCP. Next step will be to create a reference frame. I can press Alt and move it around. I'm going to press F2 to rename it. I could have also right-click rename. Again, all things that you can learn in the basic guide series on YouTube. So let's call this one part 1. I'm going to Control C and Control V on the station here. I need to, not yet. I'm going to delete this one. I'm going to place it at a specific position. I want it to be at 500 and minus 200 here. Okay. So it's the position. I'm going to Control C and then Control V this one. F2 to rename. I'm going to place part 2. And instead of, I'm going to double click on it, instead of minus 200, I want to put that at 200 millimeters. Perfect. So now I have 2 reference frames. I just want to take the part from this and place it there and then back and forth. I'm going to drag and drop the box in part 1. Okay. So now the part is like at the right position, but half in the table. So why is that? Pretty simple. If you take a look here at the 3D model of this 3D model, the origin or the reference frame of this cube is right in the middle of the part. So RoboDK matched the origin of the reference frame with the origin of the part, which gave us this result here. So I can simply double click the part, and I know that this cube is like 100 by 100 by 100. So if I place it at 50 millimeters in along the z-axis, it will work perfectly. Cool. Now that we have our station, I can just boom, position that right like this using Alt and the arrows. Double click the robot. I do not want to have world as the activated reference frame, so I want to have part 1. I can right click and click activate reference frame, or in the robot panel I can simply here click part 1 and this one will be activated. Perfect. So this will give me the opportunity to see the orientation and position of the TCP with respect to this one. So I want it to be completely normal to the surface. So perfect. Okay. Next step I could do is like bring the robot to the right position manually, or I could try to use a shortcut if the origin is in the middle, like it's the case right now. I can right click the box and say, okay, get with robot here, and click the right robot. So Deucin, boom. Now RoboDK matched the origin of the part with the TCP of the tool, so tool center point TCP. It's a bit too low, but still it's close to what we want. So the only thing we need to do right now is maybe bring it up a bit. I believe that 85 is the right number. Perfect. So now that part 1 is activated, I can create a target. It's going to be part of the activated reference frame. I can call this one pick place underscore part 1. And now I need to create the approach movement. So I'm not going to go directly to the part. I need to go somewhere over it. So I'm going to go for 200 millimeters right here. And I'm going to create a new target, F2. This one will be called app part 1. We have the approach and the picking position. Okay, so now we're ready to create the small program that will pick this part. But before going there, I will show you a trick that will save you some time, so much time and so much struggle in your pick and place application. So you're gonna create a new program, and you're gonna call it replace objects. In this program, you will right click, add instruction, simulation and event instruction. In the drop down menu, you will click set object position relative. You will select both objects in the station, the table and the box, or whatever you need. You're going to click OK. Now what this will do is that if I ever double click the box and decide to move the box around, so let's say 500 along X, if I click replace object, boom, the object goes back to its original position. So it's a way to reset your station, if I can say. Okay, now let's go for the real deal. Let's create a first program, call it pick part 1. We will need to start by going to the approach position. So select control, select the program, select the reference frame, select the target for the first time. Okay, approach. Now I will go to pick in a move L. So move L to pick. Perfect. Now I need, so if I go there, now I actually need to attach the object to my gripper. So I can either click here on add an event here, or right click here, add instruction and simulate event instruction. And by default, this window will appear with the attached object, the gripper that is activated, and yeah, that's pretty much it. That's pretty much what we need to do for the moment. So now that we are attached, we will need to go up back to the approach point. So let's create a linear movement, and let's go to approach, or let's go even to home, right click, move home, and pick part. Boom. Cool. The yellow line that you see here is the path that the robot, the TCP followed to achieve the task. You can remove that by right-clicking display path or click and F7. Okay, now let's jump to the dropped object. So we need to drop the object on the part 2 reference frame. So let's start by activating this reference frame. So this way here, the values that we'll see will be with respect to part 2, between the TCP and part 2. So you can see them moving as I'm going forward. I want to have that at 0. I'll create a first target right here. I'll call this one app part 2. And I'll go at 85 millimeters, and I'll call this one F2 pick place part 2. Boom. Okay. Perfect. So now we can create the program that will drop the box there. So theoretically speaking, we are at approach there. So let's create a new program, place part 2. Click part 2, the approach and the program, a move J, a move L to the pick and place position. I'll already create the move L back to the approach. This will save me a bit of time. And here I can insert the detach feature in between those by right clicking the move L, add instruction, and whatever instruction I will add will be placed after this this instruction I right clicked on. So simulation and event instruction, again by default it's attach object. We'll click the drop down menu and click detach object. Here we need to have the TCP which has the box in it at the moment, so it's gripper. We only have one gripper at the moment. And the very important part is to detach this part on the right reference frame. So in this case, we want to detach it on part 2. So we want it to be part of part 2 afterwards. So click there. If I click there, boom, and the box is now part of part 2. I can replace object, can click pick part 1, place part 2. F7 to remove the trace. Okay, now let's bring back that box there. So create a new program, super simple. Pick part 2. Gonna go a bit faster again. Move J, move L, move L. This is just an attach movement, so add instructions, simulation, attach, perfect. Excellent. So now I can pick this. You don't need to see the path, so I just press F7. And lastly, place part 1, where I can go there and there with a move J, with a move L, and again to approach with a move L. And I can add the instruction to detach the object, but this time I want to use the part 1 reference frame. Click there. So if I replace the object and I go one step at a time, so I don't want to see the path here. Perfect. So pick 1, place 2, pick 2, place 1. I can take all those program, right click, and then make main program. It will just like place them in order in the main program. Boom, 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 and boom. Display path, and I can right click here and click loop if I wanted to loop endlessly. It will just like do the same task over and over again. I can press escape to stop it. And if you want your station to be a bit clearer, or cleaner in fact, you can hide all those reference frame and targets. Pressing F7 again, you can do the same with the TCP and relaunch the main program. So as I told you, creating a simple pick and place program is very fast. This one doesn't do anything very interesting, but you get the concept. This was my goal. Okay. Next example, we have here just a flat part, so a flat sheet of whatever that we need to take to pick with a vacuum gripper. So I already created the station with the program, so I'll just start it. And oops, I'm taking the table. If I do it again, instead of picking the plate, I'm picking the table. Obviously, this was on purpose to show you what kind of problem or issues you'll be facing. So this happened for a very simple reason. If I right click the attach instruction that I've used here and click modify, you can see that here we didn't change anything in the last example I showed you, but now we'll have to. So the action here attach is right. The select tool is vacuum. We only have one tool, so this is right. And after that, it's written measure distance as default station, and default station is the first one. So TCP versus object position. You will see, okay, my TCP is right here, and the object is there. I should pick it, but this is not how it works. It's not like the object itself, but the reference frame or the origin of this object. So if I right click the object and click visible object frame, you will see that this is the origin of this part. And if I do the same with the table, the origin of the table is right there. So when you just use attach without any option, it will simply try to pick the object with the reference frame or origin the closest to the TCP. So in this case, it's obviously the table. So I can just replace object. Here we can press F3 or right click and modify. And what we'll do, we'll use TCP versus object surface and click OK. Now if I do that, boom, I do not care about where the origin of the part is. I only care of the distance between the TCP of the tool and the nearest surface I can find. So this was one of the options. If I open this one here, we have to take care of another option. So here I have two parts that are one on top of the other. So a green one and a blue one. If I pick part here, it picks one. If I replace object, it picks the other one, replace one, boom. But let's say that I want to pick one and not the other. So at the moment, it's only taking the first one in terms of the list we have here. So right now, if I do it, it will pick part one. Boom, part one. Because by replacing it, the order is reversed. If I do it again, it will take part 2. So if I click here and press F3 or right click and modify, I have again other options that I can use. So here I have TCP versus object position, but within a list. So it will ungrade or color this list here, means that you can select it. And I say, okay, I'm gonna take part 2 this time. Click OK. Now if I run it, nothing happens. And this is again very normal. Because if I press F3 again, here you have the distance, maximum distance. It will only look for objects which has the object position or reference within 200 millimeters. But between the part target here to pick the part and this corner here, there's like 300 or 400 millimeters, something like that. So I need to increase that value. Let's say 500, I know that it's safe. It would be the same for object surface, by the way, because it will try to find a list of objects that have their reference frame within 500 millimeters. So if I click OK, and now I do that, boom, I can pick the first one. And if I want to pick the second one, I just come here, click that way, boom, and I'll pick part 1. So this way you can really differentiate which part you take if you ever need to. Sometimes it's a bit like if the parts are very close to one another, like sheets, for example. I had a customer that was pretty much playing with like 2 millimeters thick, and sometimes it was like picking one part that was underneath and bringing it on top, so it doesn't make any sense. So we added that recently. By the way, RoboDK is a very active project. We are always improving our software, so you need to keep up with them with the version. So we're releasing like a few versions every month. So I recommend you just to go help and check for updates and see if you are up to date with our version. Okay, so let's go for the real deal. So if I replace object, here, let's start this one real quick. So we will do exactly this representation here. When we have, because now we have a few seconds while it's running, I really encourage you to go down and ask question in the chat. I'll be very happy to answer you in maybe like 15 minutes or so. So please interact with us. We're there in a live exactly for that. Don't know if we'll have the time to answer everyone's question, but at least we'll try to do our best in that area. Perfect. So let's go to this station here. So it's pretty much the same station, but without any boxes on the palette and no targets, and in fact pretty much nothing except for the linear rail that is there, the conveyor and stuff like that. So little spoiler, the next webinar that we'll do will cover basic mechanisms. So we'll create a custom linear rail, we'll create custom conveyor, maybe a 2-finger gripper, small turntable, like stuff like that. So we'll go for basic mechanism in the next webinar. So register if you want to have more information about RoboDK. Okay, so now at the moment we have pretty much nothing. So I'll just bring here, I have a folder with the box inside. I'm gonna click, drag it on my palette reference frame. This way it will appear right in the palette reference frame. I don't need to see that anymore. I'm just gonna hide this part right there. Cool. So now that it's done, we need to like multiply it. So in this case, we have 27 objects to create. So every column has 3, every row has 3 rows, in fact, and in terms of height, there's again 3 rows to do. So it's 27 objects. Usually a newcomer with RoboDK would do like all of those one after the other, placing them manually, creating the targets manually, and it would take like forever. So you guys maybe are wondering how I will create this example in as little time as I have left. So buckle your seatbelt, we're starting. So first I'll open this here. I coupled the linear rail with the robot, so now everything is working together. I'll show you how to do that in the next webinar. First thing I will do is right click, show the TCP. I need to have a visible TCP right here, and I'll move this a bit like that. Perfect. Okay, so I know that one box is around 152.5 millimeters. So I will create my first target at this height, but I'll place, let's say, my linear rail at 225. That looks great. I'll press Alt to move my robot TCP around a bit, placing it where it should be. That makes sense. Make sure that here palette is the activated reference frame. Okay, perfect. Now I'm gonna create a first target here, and I'll call this one T for target box 1 because it's the first row, and this one will be called box 1 because it's a box of the first row on 3 rows. Okay, so now a standard RoboDK user will simply like Control-C, Control-V the box, place it manually, Control-C, Control-V the target, or maybe just create the target manually, and it will take forever. So what I'll do, right click here and add a reference frame. It will create a reference frame randomly placed there. I'll right click on it, reset its position. So now its position is at the origin of the palette reference frame right here. I'll select those two objects, so the box and the target, Control-C, select the reference frame, Control-V. So now I have it's duplicated on top of it. I'll just click the reference frame, and I know that this box is 300 millimeters long, so I can bring that to 300 millimeters. So more than just having the new box, I also have the target with it, so this is interesting. I'll Control-C and Control-V again the reference frame, and now I'll place it at 600 millimeters. Perfect. Cool. Now I have that. I can, for this time, I'll have to do it manually one by one. Right click, change support, place that on palette. This will simply change the reference frame without modifying the position of the object with respect to that new parent reference frame. I'll do the same for the two targets. Perfect. I can delete those two reference frame, select those, right click, move before. I want them to be in the same, like all together grouped with a type of object, so targets and object. I'm gonna create a new reference frame again that I'm gonna reset its position so that it's at the origin of the palette. Select all those, and now I'm gonna create the two rows that comes afterwards. Control-C, Control-V in frame 7. I know that those boxes are 200 millimeters wide. Can do that once. Control-C and then Control-V. I can do that a second time. Boom. Now I have the first row done, the first layer, if I can say. And I select them all, select them all, and then right click, change support to palette, change support to palette. Oops, I thought I selected them all, but it looks like it was not the case. Just want to make sure that they are in the right order. So after, boom. Okay, I'm gonna bring them that before. By the way, to do that, I'm just right clicking before dragging. So change support palette, change support palette. Perfect. I don't need those reference frame anymore. I'll create another one afterwards. Okay, so now what I can do is like select all the boxes, right click and rename group. This is great because those are the first layer, and if I do that, you can see that it's box 1, 1, 2, 9, and I'll do the same for the targets. So rename group, T box 1, 1 to 9. So now you can see the boxes are all there in the order I created them. And same for the targets, they are in the same order as I created them. Now we need to create the other layers of boxes. So right click, add reference frame, again reset the reference frame, select all the boxes and the targets, Control C, Control V, select the frame. I can modify the position. Here I know that it's 152.5. Okay, and I can Control C that, click on palette again, Control V that, and this one will be 305. 305. Cool. Now I can rename those by group, rename group, and this will be row 2 or layer 2. I don't really know how to make the difference between those. Okay, and this is 3, and this is 3. Again, renaming and moving, in fact, change support of many objects at a time is a fairly new feature. So you need to have the latest RoboDK version installed on your computer if you want it to work. And change support again, pad it. Don't forget that you can send us any questions at the moment. We'll answer them in a short moment. Boom, now I can delete those two. I can bring that, right click, drag, and I want it before. Bam. Okay, so now we have our palette. So cool. Okay, but now we have some problems. As you can see, there's exclamation mark on a lot of the new targets that we created. Those are because they are out of reach considering the position of the linear axis at the moment. So if I simply hide the last row of the last layer of box, you can see here I can reach this one, I cannot reach this one, cannot reach box 2, 2, cannot reach box 2, 3, can reach box 2, 4. So what I'll do is I'll simply modify this target so that the target X, Y, Z and orientation stay the same, but the position of the linear rail to reach that position will change. So I can right click and options or press F3. Here in the blue box you can see the value of joint 7 or the linear rail. So it was 225. This is what I entered to start with. Now I need it to be 150 millimeters higher. So 375. I'll Control A, Control C to keep that value. Click Enter. I'll do the same, F3. Control A, Control V. F3. Control A, Control V. F3. Control A, Control V. And we're doing that for all the boxes in this second layer. It's not a very long process. Wow. Okay, F3, Control R, Control V, sorry. Now we can verify if everything works properly. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, we can bring back those visible, and now we can do the same with the third row. So it's gonna be 525, something like that. Control A, Control C, and I'll do that for all of those. Okay, while I'm doing that, I can talk to you. Little spoiler, so what we're doing right now is, some of you will say, I'm pretty sure, way faster than the standard version of just doing those targets and those boxes one by one. But we are working right now on a new feature of RoboDK. So this is really a spoiler of from our development team. We are working on a palletizing and unpalletizing feature that will pretty much do everything we're just doing right now, but automatically. So we'll just give it a one box, one position for picking, and then the dimension of our, let's say, how many rows, how many boxes by how many boxes, and it will do it all like automatically. So we will save a lot of time. I just can't wait for this new feature to come. I'm honestly quite excited. That will simplify my work a lot. Okay, we forgot to do something. Okay, now we have all the boxes, but we need to record them. So you can just I already created the replace object program. Right click and record all objects, and now all the objects that were created right now are recorded and will be replaced at the right position. Okay, next step will be to create the approach point to pick and to approach and retract from the box. So to do that, I'll simply from box 39, I'll simply go upward. Let's say 1050 is enough, and I'll move a bit in this direction and a bit in that direction so that the boxes do not rub on the other one, or let's say touch the other one when they are moving upward. And let's create this. Okay, let's call app palette. Interesting thing, at the end of the webinar, I'll give you a link and you can have access to all the station I showed you today. So you'll be able to start from the exact same point as I did and build your way up. And this webinar will be available as a replay, and it will also be available on our YouTube channel as soon as possible. Okay, so now we have here, I already created beforehand to save a bit of time the skeleton of the program. So we need to do a go home, approach palette, a drop on conveyor, and a pick program. So let's start with the go home. This one is easy. I already created in the world the home. So let's just select the home, world, and the go home. Now we have a home, perfect. The approach palette is pretty much the same concept. Palette, the approach, and there, boom, so I can go to approach. Don't need to see that anymore. And okay, and I can go here directly to this one. Cool. I will create the pick program. Pick program is pretty simple in this case. Add instruction, it's only gonna be an attach instruction. So attach, click, this is pick. Perfect. So now if I click on it and I go back to approach, I have the box with me. I can press plus a bit so that my TCP is a bit wider than the box itself. Okay, now I need to create the two targets, the approach and the drop targets on the conveyor. So I'm gonna close this, I do not need to see it. Now the conveyor belt base will be my activated reference frame. I won't change the height of the linear rail. This makes sense to me. Just gonna move it a bit, so somewhere like this. I'm gonna create my target. Sorry, create my target. Perfect. F2 app conveyor. I think I created another target. Yeah. Anyway, okay, perfect. And now I simply need to go down to the conveyor. I'll just use for this case the linear rail. So yeah, this makes sense. This will be our drop conveyor. Same syntax. Okay, cool. So to drop on conveyor, we need to select conveyor, approach conveyor with a move J. We need to reach the conveyor with a move L. Then we'll have to go back to approach with a move L, and I can right click here and add the detach instruction. So detach, and here I need to drop it on the conveyor front frame. I'll explain you in the next webinar why exactly there. This is this is a part for the next webinar. So don't forget to register. I have a lot of things to show you about RoboDK. So if I go back to app conveyor or even to app palette, I can come here, boom, and now this is part of conveyor. Perfect. Replace object, everything goes back to its original position. Now we simply need to create the main program that we have. So to do that, right click, add instruction, and we'll add some program calls. So the first program call, we can click select. The first one will be go home. We'll just like reinitiate the station. So replace object to make sure. We will start the conveyor. Okay, starting from there, we will approach the pallet. Then we will go to a certain position. I'll add it later on. We'll pick the object that we want. We'll go back to the approach palette. And then finally, we will go for drop on conveyor. By adding all those here with a jump of line between those, they will all appear here in a list. So I need to make a little change here that I'll explain you another time. So this needs to be a thread, so the conveyor will continue running even if other subroutines are called. And just, okay, so go home, replace object, run conveyor, approach palette. Now I need to go down to one of the position. I'll start by going to box 39. So I'll just add here after approach, I'll just add a move J to this position right there. Boom. We'll pick the part, we'll approach, and then we'll drop on conveyor. Cool. I can press escape, replace object, go back home. Now I know that this little routine will simply like repeat itself for all the parts. To shorten a bit this tutorial, I'll only do the first layer, but it's pretty much the same concept for the other ones. So I'll just like Control C, Shift, select, Control C, and then Control V 3 times for the first row, let's say, and then again Control C and then Control V 2 times. So now I have the same project, the same sequence of movements. In RoboDK, you cannot, with the UI at the moment, you cannot do for loop or stuff like that. You can do that using our API, but not using the GUI, graphical user interface. So yeah. Okay, now it's pretty cool. We're going, but we're always picking the same box at the same place. So I'm just have to right click the movement, link target, and select another target to link. 7, and then 6, right click, target link 5, target link 4, targeted link 3, target link 2, and finally 1. Okay, so now I can start that. Boom. So if I wanted in like 1 minute or so, I could add the other 2 layers, but that wouldn't add much to the webinar, so I do not want to like stretch up the time too much. Perfect, so I can press escape. I could, let's say, hide all those targets because it doesn't look super good when there's a lot of targets everywhere. I can do the same with the TCP. And we have a pick and place simulation ready to be shown to a customer or used for planning purposes and stuff like that. Okay, that's pretty much everything for today's webinar. If you think it was helpful, please hit that like button and subscribe to our channel. We will release more of those in the future. You really don't want to miss any of this. And remember, if you have any technical questions, you can reach us via the forum, so www.robodk.com/forum. We'll be happy to help you with your project. Have a great day.